Okay, today what we're going to practice is multiplying decimals using patterns. Okay, now at the beginning of school we talked about multiplying times 10 and dividing by 10, or multiplying by 1/10. Finding 1/10 of a number, and we talked about moving our decimals to the right or left based on whether we were increasing in value or decreasing in value. So let's just refresh our memory. Let's think about what this number would be. So 7 times 10 we know would be what? 70. But have we moved a decimal? We talked about moving our decimal to the right if we multiply by 10 because we are increasing in value. So we can have an understood decimal in a whole number. It's after the whole number because this is the ones place, and the 7 stays in the ones place if we put a decimal after that. If we multiply by 10, if we move, we're saying we can move the decimal over one place value position to get an answer. And this is true. We move the decimal over, we have 1 0. We've moved it over from here to here, and we just made a place value position and showed it as 70. Let's practice another one. If we have 45 times 10, we can say that we have a decimal right here. Okay, we have no decimal place value in this number, but we want it to increase 10 times as much. So we're saying we can move the decimal over to the right one time. If we're multiplying by 10, there is 1 0, so we will multiply it and move that decimal over one time. 1 0, one time. So our new answer will be, we can write the original number, which is 45. Here was our decimal. We'll move it over one time because we're multiplying times 10. Make that new place value position, and it becomes 450. Well, let's apply that to when we have a decimal number to begin with. So let's say we have 2 5/10, and we want to multiply that times 10. There's 1 0. We're multiplying. We're making an increase in place value. So we need to make that decimal move over to the right one place. Okay, it's just a pattern. Times 10, move it to the right one time. 1 0, we move it one place to the right. We are increasing in place value. So that would equal, we had 2 5/10, we're moving it over, and now that new number is going to be 25. So I could just erase my movement. Our new number is 25. Let's practice another one. We're just moving our decimals. Times 10. Okay, so 5 27/100 times 10. We want 10 times as much. So if we thought about rounding, okay, if that's to the nearest counting number, if this rounds to 5, what's 5 times 10? Well, it's 50. So we need to make sure, just think of what's reasonable. 5 times 10 is 50. So if we just move this decimal over one time, won't we have a whole number that's close to 50? Yes. If we move this over one time, we will get 52 7/10. So let's record that, 52 7/10. So if we think about, again, the rounded numbers, we have 5 times 10, which is 50. Isn't it reasonable to say that 5 27/100 times 10 is somewhere close to 50, 52 7/10? We can also do the same thing, but move over twice if we're multiplying times 100. So let's practice that. Let's say, for instance, we had the whole number 8. 8 times 100. We all know that that would be 800, but let's see why. If we think about moving decimals, here is our decimal. You can always place a decimal after the whole number. How many zeros are there in 100? Well, there are 2. So we would increase in value 2 times to the right. 2 zeros, 2 times to the right. 1, 2. And look what's happened. We need to create 2 new place value positions, and that's why we recorded our answer as 800. Let's practice by multiplying by a decimal number times 100. If we have 3 and 1200ths times 100. Well, think about rounding again. Let's think about what's reasonable. 3 and 1200ths to the nearest whole would round to 3, wouldn't it? Because we look at the tenths place and it stays the same. So 3 times 100 we know is 300. So we know our reasonable answer would be close to 300. So if we move over 2 times, we know that we will go here, then here. So let's record our new answer. It would be 3, 1, 2. If we put a decimal here, we could put a 0. It'd be 312. And that's awfully close to what our estimate said that it would be. 3 times 100 is 300. So 3 and 1200ths times 100 is 312. Great, right? We can do the same thing times 1,000. We want 1,000 times as much. So if we have 4 and 5700ths times 1,000, following this pattern, how many times do you think we will move our decimal to the right? 1, 2, 3 zeros. So we're going to move it over 1, 2, 3 times. So let's think about what's reasonable too. We know our answer is going to be somewhere close. This would round to 5. Well, what's 5 times 1,000? It's 5,000. So we know our answer to this equation is going to be somewhere in the neighborhood of 5,000 when rounded. So let's look. We're going to move our decimal over 3 times. 1, 2, 3 zeros. 1, 2, 3 times we will move to the right. If you don't have a place value position, make one. So our new answer would be 4,570. So let's think about what we said originally. We said that 4 and 5700ths would round to 5. We know that 5 times 1,000 is 5,000. Isn't our new answer somewhere in the neighborhood of 5,000? Yes. Now we can do the same thing with multiplying by decimal values times 1/10 and 100th and 1,000th even. But we're going to go in the opposite direction. So now instead of increasing in value and moving to the right, increase to the right, what do you think is the opposite of increase? It's decrease, and the opposite of moving to the right would be moving to the left. So let's look at multiplication patterns when we multiply by 1/10. So let's say we have 7, and we are going to multiply 7 times 1/10. What does that mean? We want 1/10 of the value of 7. We want a part of, because isn't that what a fraction and a decimal are? It's part of a number. So we're not making it larger. We want a piece of 7. So if we only want, excuse me, if we only want 1/10 of 7, we know that our value is going to be smaller or decrease from 7. So we're going to move over, look, there's 1 0 in 1/10. There's 1 place value position in 1/10. So how many times do you think we're going to move to the left from our original number? 1 time. 1 time. So here is our original decimal. We're going to move it 1 time to the left. So our new answer would be 7/10. Let's look at a little bit of an easier example. Okay, if we have $1 whole, just $1. Let's say this is money. What would 1/10 of $1 be? Okay, what do we need 10 of in order to make $1 whole? Well, that's a dime, isn't it? Well, how do we make $1 whole turn into a dime? Well, we multiply times 1/10 because we want 1/10 of this number, and we're going to move our decimal to the left, 1 place value position. 1/10, 1 place. So we're going to decrease in value 1 time. So that equals, we would move our decimal here, and isn't that 1/10? And we could put our, if it's money, we would be putting a dime, which is 1/10 of a dollar. Okay, it's just a pattern. So what if we had 52 times 1/10? We're not multiplying by, we're not making it greater, we're decreasing in value. We want 1/10 of 52. What can we put together 10 times to get 52? Is what we want to know. Okay, let's see, where would the decimal be in the number 52? We need to keep it a whole number, so we can put our decimal here after the whole number. So how many times will we move our decimal to the left? We're decreasing in value, 1 place value position, and there's 1 0 in tenths, right? 1/10. So we're going to move this over to the left 1 time. So 5 2/10 is 1/10 of 52. We can use the same patterns when we multiply by hundredths. So let's say we all know that if we have 300, 1/10 of 300, or 300 divided by 10, would be 30. So let's go ahead and find out why that is, times 100. How many decimal place values are there in hundredths? There are 2. And let's look at 100th as a fraction. There are 2 zeros in 100, so we're going to move our decimal over 2 times to the left. So if we only want 100th of this number, oh, I said earlier that it would be 30, I think. It's going to be, I was thinking tenths. Of course it's going to be 3. Okay, 300 divided by 100 is 3. Okay, so we're going to move this over 2 times. I apologize. Okay, 2 times to the left. We're decreasing in value. Of course, if we go from 300 all the way down to 3, that is definitely a decrease in value. We can write it like that, or we can leave off the decimal and the zeros. Let's do another one. Okay, if we're multiplying by hundredths, we're moving over 2 times to the left. We're decreasing in value. Okay, so let's say we have, I don't know, I'm just making numbers up, 827 and 1/10. We can do that. We can multiply that times 100th. That means that we want 100th of this number. So we're decreasing in value. So what we're going to do, there are 2 place values in 100th, that decimal number. There are 2 zeros in that 100. So we're going to move over 2 times to the left. So our new value will be, let's rewrite it, 8 271 thousandths. Okay, because let's think about this. If we started off with 827 and 1/10, if we rounded this to the nearest hundred, that would be 800, and 800 divided by 100 would be 8, wouldn't it? So that's all we're doing, is we're working with patterns, and we're moving our decimal to the right to increase or to the left to decrease. So let's do one more problem, and then I'll let you on your own to practice. Okay, if we have 9, let's do a hard one. 9 57 hundredths, and we want to find 100th of that number. We can multiply by 100th. How many place values are there in 100th? There are 2. This is your clue to help you know how many places to move. Since we're decreasing in value, we're going to move to the left 2 times. 1, 2, place your decimal. We need a spot there. We will put a 0. So, oh, look at that. That's going to be great. We will have 957 10,000ths. Wow, that's a tiny, tiny number. So we went from 9 and something to 957 10,000ths. We would need a whole lot, all these tiny pieces to equal that. Okay, so we're decreasing in value. So let's just remember one thing. When we're increasing in value, times 10 times 100 times 1,000, we will move to the right. Yes.
I need Eric here to leave.
They're in specials, PE.
Oh, okay. I'll call him.
Thank you. If we are decreasing in value, if we multiply times 1/10, or if we're multiplying times 100th, or even 1,000th, we are decreasing and we will move our decimal to the left. All right, good luck everybody.